Failing to plan is planning to fail. So failing to plan for change is planning to fail your changes? Anyway, I'm Ray Myers. Welcome to Craft versus Cruft. Today I'd like to talk about an unspoken, often principle that lies behind a lot of the architectural reasoning that senior engineers do and try to help you get into our heads. And that principle is change. In particular, that a good design must be able to accommodate change. So we can talk till we're blue in the face about coupling or the solid principles, about dry, don't repeat yourself, removing duplication, object-oriented design patterns, architectural patterns, enterprise integration patterns. What are we trying to actually do though? We're trying to accommodate the fact that the current design of the system is not the final one. The current requirements are not the final requirements. The current decisions we've made are not the final decisions. How good our architecture is only going to be borne out in the fullness of time by those changes occurring as we see how well we've anticipated them. This is notoriously difficult to teach. These are judgment calls that some would say only experience can give you. But I'm going to try to at least give you a feel for the direction you want to be pointed in as you develop your own understanding. Let's start with a concrete example. Not long ago, I was talking to a friend of mine who's a developer earlier in his career. Let's call him Jay. And he was asking about some of the finer points of how he should organize his architecture for a project he was working on for a client. This had a component that was a mobile app, cross-platform, written in Flutter. It had a server-side REST API, so fairly typical. Client calls the server manages database calls. I believe it was a Node.js app written in Express. So we're walking through the various components that are going to be developed. So I say, okay, there's probably going to be a layer of validation and transformation that interfaces between the format that's stored raw in the database and the app domain objects. Where's that going to be? And he suggests, well, perhaps we'll put it in the mobile app. He was probably suggesting that first because he was more comfortable in that part of the code base. But I asked him, what's going to happen if your data format needs to change at all? Suppose you need to adjust your table structure. What would happen then? Well, the Flutter code would need to change. Okay, it's me again. What happens then? How are you going to roll that out? You're going to need to build a new mobile app and release it on the App Store and then wait for some dominant portion of your users to upgrade. And even then, you're going to have a mix of clients deployed out there that are going to expect the old data format and the new one. This is a very difficult rollout strategy for what should be a pretty routine change. Thinking through that, we realized that the data interchange layer ought to all be on the server side close to the database and something that you have control of rolling out independent of your users. So hopefully I saved him some future grief there. But it occurred to me that you can read about design principles all day and still not understand the context that they're in and what you're trying to actually accomplish, which is to accommodate the sorts of changes that are likely to occur. One of the things that you'll do as a senior engineer is be constantly, as you're looking at a code base, running simulations in the back of your head without even realizing it maybe, looking at the assumptions that are explicit and implicit in this design and what would happen if any of those assumptions didn't hold true in the fullness of time. How dire would the consequences be? And weigh that against how likely any of these scenarios might actually be. Some of the more experienced interviewers I've worked with have said that they look for at least one long tenure in a senior candidate, not just to prove that they don't job hop constantly, but so that they've seen their designs bear out. If you just put something together and run off before it comes crashing down, then you're missing a lot of learning there. Now, said that by and large, the industry considers this the sort of thing that experience is the main teacher of, but I should point out there's a very interesting approach by a professor named John Ousterhout, and I'll link a talk he gave at Google in the description. He has set out to meaningfully teach software architecture within a college curriculum by a very interesting approach of having students create a meaningfully sized code base over the course of the entire semester, and then have to maintain each other's later and in various ways share the learning from that. I think it's a very interesting approach. I'd be interested to see any follow-up work that's been done on that. I can at least say that in my degree program, I certainly learned, all the ways that you can use OO and C++, how inheritance works, public, private, all that. I barely understood the first thing of how you can apply these concepts to make a code base stay maintainable as it scales. Because they can teach you the buzzwords, but if you're just looking at 100, 200 line programs for all your assignments, you just don't see the context any of this is meant to apply in. You're not working on anything that could meaningfully even be called a system. So for that reason, I think it's very important that concepts like architecture and maintainability and refactoring are increasingly becoming more of a first-class concept, whether we're talking about within a university curriculum or just within the body of industry literature. These really need to be addressed as fundamentals. In an article called A Software Architecture Guide, Martin Fowler says, "Good architecture supports its own evolution." And if you know Martin Fowler, you know that it's worth a read. And if you know me, you know the links in the description. There's even a paradigm intending to take this to an extreme called Evolutionary architecture. This book on it just came in. I'm looking forward to reading it. 3 authors including Dr. Rebecca Parsons, who's the CTO of ThoughtWorks. I'd love to go into some more depth about how this all applies to various specific design patterns and principles that you may be familiar with. So I think I'll spin those off into future videos. Please feel free to subscribe, leave a comment, let me know what you want to hear about next. Till then, Happy New Year. I hope yours changes for the better. Always remember what Lao Tzu said in the Tao Te Ching, "With patience, the most tangled cord may be undone." Thank you.